Yes, class, am I audible? Neha, Simra?
Yes, ma'am.
All right. Let us just discuss the assignments first. These two assignments are pending from the previous chapter. Then we'll move on to the next one. I think in this fourth and fifth question, you had an issue. First was done, second was done, and third was, yeah, fourth and fifth. Look, fourth question says that two tall buildings face each other and are at a distance of 180 meters from each other. Like two buildings are there and they are separated to each other by a distance of 180 meters. Then it says, with what velocity must a ball be thrown horizontally from a window 55 meters above the ground in one building so that it enters a window 9 meters above the ground in the second building. Okay, look. See, this is 10 meter. Okay. It enters a window. This is 10 meter, comma. This is 9 meter above the ground in the second building. It's like, see, here if I mark this one, that is, let's say this is 55 meter. Ball should go like this from here to here. And this distance till this point is 10 meter. This is what the question says. Okay, now we have to find out with what velocity must the ball be thrown. Means our initial velocity u. And it's a case of horizontal projection. So look, when we are talking about the height difference between them, this is 55, this is 10. If I calculate it like this, let me assume that this is the ground level. Okay, I am just taking a parallel line at this point. Look, I'll just redraw this. Let's say this 10 centimeter class is lying here. This is 10 meters. And the ball is going from here to here. So if I just take a line parallel to the ground like this will still be 180 meter class. Even if I take a parallel line here, this will be 180 meter. Whereas this height will be, what will be this height now?
55 minus 10.
Yes, 55 minus 10. So this becomes 45. This is 45 meter. Okay. So see, for initial velocity, now you can use the formula also. You can directly say along the y-axis, see what will be y? ut plus half at square. Everything in terms of the y-axis. Correct? Everything is in terms of the y-axis. So your y is, this is what? 45. So this becomes 45. Uy, we do not have any uy along the horizontal projection because this is a horizontal projection. This is what we are trying to calculate. So this will be 0 and half a t square time isn't given. So time we have to calculate from here. This will be 99. So 9 under root 9, 3. So time will come out to be 3 seconds. Till here, is it clear? Time will be 3 seconds. Clear?
Yes,
Okay.
ma'am.
Now see, for the horizontal velocity, you just require horizontal time and horizontal distance class, right? What is the horizontal distance over here? 180. Time is 3 seconds. So straight away, you basically have the range of motion as 180. You've got the time as 3 and you want the value of u. So how will we calculate it? Or directly you could have used from here. You can put it under the formula also under root 2h by g. Same thing will come. So time period will come, range of motion is there, time period is there, initial velocity has to be calculated. So if you see, this is just a question where you have to use first the range of motion. Mainly if you get the figure correctly, you will be able to write the rest of the things fine. So range of motion is 180 meter, time period is 3 seconds. So from here you can directly use R is equal to U into T, which you can use as under root 2h by G. Means directly also, if you want, you can use this formula because this is the proper formula for the range. But it's just that in this question, you have to show that this is separate 45 meter, this is the length. So that is how the difference comes. So this will be, U will be 180 by 3, which is equal to 60 meter per second. That's that. Okay, coming to the next one, or do one thing, just I think Simra did this fine. Simra has used this formula directly. Yes, Simra? Directly you have written R is equal to U under root 2 H by G.
Yes. Yes, ma'am.
Neha, you please quickly copy, then we'll move on to the next. All right, coming to the next question. So this says that a fighter plane flying horizontally at an altitude of 1.5 kilometer with a speed of 720 kilometer per hour passes directly overhead an anti-aircraft gun. Okay. At what angle from the vertical should the gun be fired for the shell muzzle speed? Okay, fired for the shell with a muzzle speed of 600 meter per second to hit the plane. See, it's like at an altitude of, what's the altitude? 1.5 kilometer. 1.5 kilometer. Here a plane is moving. Okay. So here you have the aeroplane moving. Now look, this says this is moving with a speed of 720 kilometer per hour. So this is moving with a speed of 720 kilometer per hour. Now see, here you have shot the gun and the shell has a muzzle speed of 600 meter per second. Okay, this is in meter per second. And it says at what angle from the vertical. So we cannot take this angle. See class, we usually used to take this angle, but we won't be taking this angle. Now we'll be considering this angle because it says from the vertical. Okay, it says from the vertical we have to find it. Okay. So see here, when the means the bullet hits the plane, both of them will travel the same distance. Means whatever distance the plane will come, let's say it is coming here till this point, and this is coming here. So let's say this point. This is a particular point where both of these will coincide, right? Then only it will be able to hit it. If the plane moves, if the plane stays here and the bullet has been shot, so it would miss its target. So whatever is the distance covered by the plane is the distance covered by this bullet also, right? So I can say the distance covered by bullet is equal to the distance covered by plane. Same thing. Now see, for the plane, we can just say velocity of the plane into time, right? And time will also be the same, because if time is different, then the coincidence means the bullet will not be able to hit the plane, right? So we have to find out first at what angle we have to calculate this angle. Then let's see later. First, let us calculate the angle. Now, for the distance covered by the bullet, we again require the speed. So look here. If I have this, now resolve the vector. Yes. Neha, can you just tell me what will be the component here? Let's say this is V.
V sine theta.
Will it be V sine theta if the angle here is theta? With the axis, when angle is made, what do we take? Cos or sine?
Cos theta.
Yes, this
Yeah,
is
it's V cos theta.
because you don't see the x or y axis. You see where is your angle made. Okay, if your angle is made across the y axis, then you're going to put that as cos theta. This is not fixed that we have to take sine or cos somewhere. Okay, and this becomes V sine theta. So when we are talking about the distance, here we are talking about everything along x-axis. So we cannot take y component here. When I have taken the x component here, everything is along x-axis. See, it's a combination of horizontal motion also. No, this is simply horizontal motion, whereas this is the angular motion, right? So see, if this is the case, I cannot take v cos theta here because this is the y-axis, the bullet component which is going above. We are taking this, right? Because here also I have to consider x, so here also I have to take x. So this will be velocity of the bullet sine theta into the time. Okay, time will be cancelled from here. Now look, sine theta will be velocity of the plane divided by the velocity of the bullet. From here I'll be able to calculate, but one more thing, you cannot take 720 here because this is in kilometer per hour, this is in meter per second. So this will be 720 by 5 by 18 and this becomes 600. So this 0 gets cancelled, 12. So 30, then 1 and 3. So here will be 1 by 3, I think. Just check. This becomes 12. Yeah, 1 by 3 will come. So from here we get our theta as sine inverse 1 by 3. That's the angle, first one. Is this clear?
Yes, ma'am.
Okay. Second says at what altitude, maximum altitude should the pilot fly the plane to avoid being hit? Means first part is completely different. In the first part, we are assuming that the hitting part will occur. In the second, it is saying to avoid being hit. See, from here we can do one thing because we don't know what's the values of the angle. If this is theta, so look here, if we put it in the angle for the height, the angle that we consider in our formula that we have used is not this angle. We've always used this formula, this angle, right? We've never used this angle. All the derivations of the height and time period and everything that we have done, we have never used this one. So the formula is valid only when I use this angle. So this is theta. What should I take this angle as?
Beta. No.
What should I take it
9.
as? 90 minus.
Yes, 90 minus theta.
You said the same, Simran?
Yes, ma'am, somewhat.
Okay, then this will be 90 minus theta. Okay, so when we put it in our main formula, okay, here if you have this main formula and you're putting it, so this will be h is equal to u square. Now sine square is there. Instead of sine square theta, we are going to put this 90 minus theta. Because then only this formula is valid. We have derived this formula using this angle. If we are considering this angle, then we have to derive everything all over again, because this is not what we've taken. This formula is not made for it. Divided by 2g. Now one thing, sine square 90 minus theta can be written as
Sine 2.
sine 90 minus theta cos theta.
Cos theta, yes, ma'am.
Yes, and so sine square 90 minus theta will become cos square theta. Okay, now problem is that cos theta, from where do we get this cos theta? So when you have any of the angles, even one of the angles you can calculate value of any angle. Okay, any angle can be calculated. How? You have, let's say there's a triangle if I make. If sine theta is 1 by 3, what is sine theta? Like, how do we write sine theta generally from your lower classes? If this is theta, is it perpendicular hypotenuse? Perpendicular by hypotenuse? That's the basic formula of sine theta. Yeah?
Yes, ma'am.
It
Yes,
means
ma'am.
this is 1, this is 3. Sometimes in the question, you will find it's written sine 1 and 3. This is also written. That means this is the perpendicular, this is the base. In many questions, you will find after laws of motion. And yeah, in questions of laws of motion, especially, you will find this sine 1 and 3. But in your inclined plane problems, one inclined plane I've given you in the homework also. Neha, you've shared that homework. Simra, your pulley one is left. So that's why I didn't discuss that. Neha, your one is left. And the tension and pulley one was correct. Both of you, you've done it perfectly. I don't think so there was any doubt, but let me complete this first. So this is sine 1 and 3. So from here we can get cos theta. Do you get this? If you have 1, you have 3. This will be simply 3, so 2 root 2. This will become 2 root 2. 2 root 2. So cos theta becomes 2 root 2 by 3. So cos theta will become 2 root 2 divided by 3. So cos square theta becomes 4 into 2, 8 by 9. Yeah. So your cos square theta will become 8 by 9. The rest of the things you have. U square, cos square u is 600. Cos square theta is 8 by 9. 2 into 10. This you can calculate and tell me the answer. Okay, is that clear? Did you understand this question, Neha? Is it completely fine?
Yes, ma'am.
Let's write it. Then one question of the tan beta 1 we discuss. Please. Okay, so in this, I think one question was only doubtful to both of you. The last one. A particle is projected over a triangle from one end of a horizontal base and grazing the vertex falls on the other end of the base. If alpha and beta be the base angles and theta be the angle of projection, you have to prove that tan theta is equal to tan alpha plus tan beta. Any idea how do we start this question with? Okay, let me make the figure first. Till now we didn't discuss this question, no? So let me make the figure. Let's say this is the angle of projection. See, let me make the figure, then I'll discuss with you. Now I'm just naming the angles. One, it is saying alpha, other, it is saying beta, right? Now see, total angle with which it is projected, this is theta. So this means this is something like this angle is theta, this angle is alpha, this angle is beta. Okay, let's say the total distance will be, what will be this base distance? What will be this?
Oh, range, ma'am.
Range, no? This will be range. Now look, this is the range. Now we have to assume something because these are all about the triangles. You will notice only at one point, see 2 points, you're going to just use your physics. The rest is just mathematics. The way in class 10, then 9th, you had to prove the quadrilaterals questions and the triangles questions like that. This is a question like that only. One, in the figure, you need to understand the knowledge of projectile. And second, we are going to use the equation of trajectory that will be used. Otherwise, this is just a question where you have to prove the triangle. Now, let's say this is y, some distance y, this is y. Okay, and I am assuming this distance is some x. So what will be this distance then?
R minus X.
R minus x, very good. Okay, so I'll just ask you a few things. You keep on telling me. So this way the question can be solved. Tell me what will be tan alpha. Or I'll straight away write tan alpha plus tan beta. I'm solving this term first because this is a little tricky. This is a little simple. Now tell me what is tan alpha.
Y upon X.
Y upon x. Very good. And what is tan beta?
Y upon R minus X.
Yes. Y upon r minus x. So we are going to simplify it a bit. If we just cross multiply the terms, means on taking the LCM. Okay, here we are going to take the LCM. So once the LCM is taken, then we can at least have a final value which cannot be solved further. Then we can go on towards using the equation of the trajectory. Okay, so this way, this will be y r minus x plus y into x divided by x into r minus x. Did I write it correctly? Yeah.
Yes, ma'am.
Okay, now if I open this up, yr will be left. And look, minus yx plus yx will get cancelled. So we'll just have x r minus x. Till here, is it clear? Tan alpha plus beta part.
Yes, ma'am.
Yes, ma'am. Now coming to the trajectories equation. What is the equation of trajectory that we've studied? In fact, you can even, or no, here it's fine. Let's derive this only. This like now we want tan theta. Or class, we have tan alpha with us, tan beta means one side we've got. If I get the tan value of theta, this only means my answer is done. This is what we need to prove. So tell me one thing. What is the formula of trajectory?
x tan theta plus
X tan theta
minus
minus,
G
yes, not plus,
minus
G,
yes, ma'am.
gx square
Gx square
2u square cos theta.
yes, square square cos square theta. Okay, now class, I want tan theta from here, right? That's what the entire task of this question is, to calculate the value of tan theta. So if I want to calculate tan theta, I should take tan theta common from here. Like if I take tan theta common, or let me take the entire term x tan theta common from. If I take x tan theta common from this side, class look, if I've taken x tan theta common, 1 will be left here. Yeah. And see, 1x will come out, but there is no tan theta. So it means it will come in the division. So that when we open the bracket, tan theta for this side gets, that's how we take the common thing which is not given. Like, will it be gx by 2u square cos square theta tan theta? Now check, if I multiply these two things, will I get this equation back? Is it fine?
Yes, ma'am.
It's correct? Okay. See, from here, if I use one identity, can you see any identity over here? This denominator. See, for the previous step, what have I done? I have taken x tan theta common. Okay. Now x tan theta is taken common, so one side is left. So 1 is left over there. Okay. Now for this side, which is v square, x is taken common, but there is no tan theta. If I divide it, because it is actually getting multiplied. So if I divide it here, when I open the brackets, again, like if I go to the previous step, my x tan theta multiplied to this gx by 2u square cos square tan theta, this thing. It will give me, see, x into x will become x square, and tan theta divided by tan theta will be 1. Okay. Yes, coming to this identity. 2 cos square theta tan theta. Any idea?
We can open tan theta and cancel cos theta.
Yes,
So we'll
yes.
get cos
Very
theta
good.
sin theta.
It will be
Then we will get cos theta sin theta, which will be sin 2 theta.
very good, Simra. Yes, good. Very good. This is correct. See, when you open here tan theta is what we know, sin theta by cos theta. Look here, tan theta will be sin theta by cos theta. So directly this is no identity, but this is exactly the same identity which we have used in our range of motion. So cos square theta into sin theta by cos theta. This square cancels the square. So what is this? 2 cos theta sin theta? That is nothing but sin 2 theta, which we use in the range of motion. Now let's put the values. Y is equal to x tan theta. 1 minus gx by, we get u square and sine 2 theta. Is it?
No, ma'am. 2u square. There's a 2 over there.
No, but 2 cos theta sine theta gave the identity, no?
Oh, yes, yes, ma'am.
Okay. Now, from here, is there anything coming to your mind by looking at this? Anything you can think of? Like what we have studied, is it related to something?
Inverse of
Range
range.
Yes.
in
Take
yeah,
R, formula of range of motion. U square sine 2 theta by G. This is G by U square sine 2 theta. This is 1 by R. So this equation is y is equal to x tan theta 1 minus x by r. Is this fine? Now look, we
Yes,
are
ma'am.
getting the same equation. See, from here if I take this will be r minus x by r. So what will be tan theta from this side? If I take tan theta, y into r divided by x into r minus x. This is what we had over here. Did you get this? If I take the LCM here, r minus x divided by r, right? And when I want the value of tan theta, this denominator's r will be multiplied to y. X will get divided and this r minus x will also get divided. So I'll get this. So tan theta is equal to tan alpha plus tan beta, proved. Now you got this question.
Yes, ma'am.
Okay. Please write it. In the weekly test, there was one question, the last question, which none of you have attempted. Means you have not written even a single word for that question. Simra has not even mentioned the question. I cap, J cap, one question was from vectors.
No, ma'am, the page was a mess, so I did not include it.
You
I did
have
not
done
understand
that.
the question. I tried something, but nothing was coming out of it, so I left it.
Okay, no, means willingly you have not attached. No, by mistake it didn't. No,
No,
willingly you have
ma'am,
not.
willingly I did not.
Yeah,
Yes,
that's
ma'am.
what I was saying. So I just wanted to tell you that question is from your NCERT. Okay, so we'll discuss that in the next class. That question is actually from your NCERT. I've picked it from your NCERT. In the last weekly test, I didn't give it in under vectors because that would have been very tough. The paper would have been very tough. But this is a tough question that we'll discuss. But I just wanted to make you in your mind that that question was from your NCERT. Coming back to the chapter class, class from the laws of motion, whatever assignments are left, that I'll discuss tomorrow. Okay, because now a lot of time has gone into this. Let us just at least start with friction today, because much isn't left in this chapter, but let's complete it. See, we have done few questions and few assignments were also given. So in the assignments also, you must have found the questions. These kinds of questions were there. So here, see, I have not written the question directly. I have taken the figure. So question had the whole statement. A box is kept, a block of mass M1 is kept on a smooth frictionless table where a pulley was running and M2 in all the story. So what do we have to find out? What do we know? We know M1 is 10 kg, M2 is 5 kg, and we have to get the acceleration, tension during the motion, and tension when the body stops. That's it. This is what was the crux of the question. So, see, class, let's go by the free body diagram. Okay. When we have a block of mass M kept, downwards the gravitational force will act, that is M into G. So this becomes M1 into G. And here we have the normal reaction. I'll write this as N. Normal reaction will be coming upwards. This is M1 down. A string is passing, so tension will be there, directed away from the body. And here there is another mass, M2, which is moving downwards with acceleration A, and this is moving rightwards with acceleration A. So it's like one is kept on the table, one is going below. Since this is going below, it will automatically pull it like this. This is how the motion will occur. Okay, so let's talk about the free body diagram. Neha, let's start with you. You tell me for M1. This is M1. What all forces are acting?
Normal reaction,
Wave.
M1G, and tension.
Yes, yes, Simra. Just a second. Neha, can you?
M1G, which is weight, then
Yes.
normal reaction and tension
Normal
towards the
reaction
side.
and tension.
Tension.
Anything else?
Acceleration is towards the right.
Acceleration and acting towards. Any other force?
Gravity. No.
Gravity is this only, Neha? No. Say no. If there is no other
Okay, no.
force, just say no. Yeah, Simra, can you tell me for M2?
M2G acting downwards, tension upward,
Yes.
and acceleration is downwards.
Okay, why not normal reaction?
Because tension is over there and it's not in contact with the surface.
Yes, this is the reason, not because tension is there. It's not that there's a vacancy of only one force which is occupied by tension. Also, sorry, normal reaction cannot act. Because normal reaction is a contact force. See, why do we draw free body diagrams? Because you are allowed to write as many forces as you want. If there was a normal reaction occurring here, I would have written it like this. So not because the tension is there. Second reason is correct, because it is not in contact. Normal reaction is completely a contact force. Now let's write the equations. First is acceleration, and second is the tension when they are moving and when they are stopped. So see, difference is that when these accelerations are considered, that is the second part. Okay, and when we assume that acceleration is zero, that is what's the third part. So see, let's make the equations. Here normal reaction will be balancing M1G, N is equal to M1G. Now here the net force across the x-axis, is it something else present? Do we have something to balance on the back side? We do not have, according to our free body diagram. That's why we make the free body diagram, so that all the forces are prominent to us and the rest of the things that are disturbing have been removed. So we directly have tension as the force. Tension minus nothing is here right now, okay, is equal to M1A. That is one equation. Now, second is from here, M2G is acting downwards, that is along the direction of acceleration. So I assume this will be positive. Yeah. So we'll say M2G minus tension is equal to M2A. These are the two equations that could have been formed. Now, I think I can simply equate tension with this because here there is no T minus m1g, it's not along the gravity. So if I put the value of tension, I will get m2g minus m1a is equal to m2a. Let's do a bit of shifting. M2g minus m2a. No, we need acceleration. Let's shift m1 on top. Because in the first part it says acceleration, not the tension. So m2g will be equal to m2a plus m1a. From here, I can take acceleration common. So I'll get m1 plus m2 equal to m2c. Acceleration will be m2g divided by m1 plus m2. m2 and m1's value. m1 is 10, m2 is 5. 5 into 10 divided by 5 plus 10. 5 and 10 है क्या है? 5 and 10. Okay, so this becomes 50 divided by 15, which is, no, this won't be we can just reduce it. This is 10 by 3. 3.3333 meters, right? 3 bar meter per second. Is this clear? Acceleration is fine. 3.333. So you can, if you take 9.8, I think you will get a better answer with this. Because in this question, I don't remember whether it mentioned about that or not. Okay. So the acceleration first part is clear?
Yes, ma'am.
ma'am.
Okay. Second says tension during the motion means in this situation only, what we have assumed. So tension we can directly calculate from here. I think it will be better. Why to put it in bigger equation when we have the smaller one? So tension will be M1 is 5 into 10. So this will be 50 Newton. Around 47 point something it will come exactly, which should be taken. I am just taking 10, but in the exam again I'm saying don't take 10 unless stated. But in the exams, in the weekly test, you people have taken 9.8 everywhere, I've seen. You have never taken 10 when it's not mentioned. Third part says tension when the body stops. Means this time, tension when the body stops. So let's take any of the system or both of the system here. It won't affect it. Because see, tension will still be, if even there is no acceleration, what will happen? The body will be will not be moving here, right? And here also the same thing. So it's better if we pay for the second body because upward force here you have along the y-axis normal balancing m1g. There is no force to balance tension because it will be zero. When acceleration is zero, tension will be zero here, right? There won't be tension in m1 because when acceleration is zero, there won't be any tension in the first body. But here, when acceleration becomes zero, so I'll just redraw it, third part. Won't it be like M2 is there, tension above, below is M2G. And if acceleration is zero, we can say tension is equal to M2G. That is equal to 10 into 10, which is around 100 Newton. You will get the answer. Fine.
Yes, ma'am.
Okay, write it. One last question we'll discuss and then we'll move on to the last topic, friction. I think I've told you about the circular motion. We'll be doing all the entire circular motion together. Okay, entire circular motion of class 11th. Please write it, class. Oh, just a thing. M2 was 5. So this will be 50. I have taken M1's value. This is 5, so it will be 15 Newton. So when you will calculate using 9.8, you should get a better answer, around 47 point something like this answer.
Mom,
Yes, Neha.
Mom, the second answer will be 100, right?
Oh, yes, yes. This will be 100. I interchanged it, no? This will be 100. So I think exact answer should be something around 98 point something. This is what you'll get. Just a thing. Wait, wait, wait. I have written here acceleration due to gravity. This value 10 won't come. We have already calculated the acceleration. That is this 3.3. Wait, wait. C class. Instant is equal to m1a. Mass is 10. Acceleration is there. I wrote acceleration due to gravity's value. This is acceleration. This was this acceleration that was occurring here. So here we'll have the acceleration, not the acceleration due to gravity, because this is what we've calculated from our first part. So around 3.33 something we'll multiply, that will be around 33.3 Newton. This will be the answer. Mass is 10 kg, acceleration is 3.33. Got it? This part.
Yes, Mom.
Yes, ma'am.
When you write the question, then tell me, then I'll start this question, okay? Or at least tell me the value of T3. T3 can be told. Tell me the T3 tensions we have to find out. I'll discuss T2 and T1. No, Neha, I think slight mistake you've done. Simra, your answer is correct. See, let us now discuss. You have written the question, both of you. You've tried it once, right? At least T3. Let's move. Yes, no.
Yes, ma'am. Yes, ma'am.
See, as I told you, whenever you have any question, you have to draw the free body diagram. Why am I saying, see, many questions can be solved directly. Like right now, at this stage, I'll prefer to solve the questions like this only. M3G is okay acting here like this and acceleration upwards. So A, so this minus this like this. But I'll tell you, at your stage in class 11th, you are marked for writing the free body diagram. Free body diagram is a particular topic in your syllabus. So you will not get a question, draw the free body diagram of this. This question you won't get. So how will you be judged within the questions? So that's why I say have a habit of drawing the free body diagram separately. It costs nothing because whatever you will be solving, you will just draw it and separately write down the forces. You want to solve with that or not, but write the free body diagrams because they hold a score in your answer. Now see, let's start with M3. Now tell me what are the forces acting here?
Tension upwards and
T3 upwards.
weight downwards. Weight down and
T3
acceleration up.
acceleration.
Upwards.
So what will be the equation?
T3 minus M3G is equal to M3A.
Yes. T3 minus M3G is equal to M3A. So from here, T3 can be written as M3A plus M3G, which is M3A plus C. This is T3. This said, okay, 9.8 only we have to take. We cannot take. So M3 is 3 kg. This will be 3. Acceleration is 2. Yeah, 2 meter per second square. So 2 plus 9.8. So what is it coming? 35.4, no?
Yes, ma'am.
Yes, ma'am.
Simra's answer, yes. Neha, you're also getting the same now?
Yes, ma'am.
What was the mistake?
I multiplied acceleration and gravity.
Okay. All right. So 19.6 into 3 you've taken. All right. Yes. So this is tension T3 we only have. Now let's come to M2. Simra, can you try this one? Can you tell me the free body diagram for M2?
In this one, can we assume that T3 and M3 are balancing the force downwards instead of gravity?
No. Because the whole, it is saying
No.
whole system is going up. So when the whole system is going up means all the 3 masses are going up together. Just tell me the free body diagram. I'll help you with it. There's just one catch in this question and you all will be able to do the rest of the questions like this. Tell me what are all forces are acting.
T2 will be upwards and
Yes. And
T3 will be downwards.
T3 will be downwards. Anything else?
M3 is also there, I think. No, I think we'll just take T3.
Okay. See, let me help you. This part is fine, Simra. T3 will be acting. Understand this. See, how is this happening? T3 is acting upwards like this, right? This is what is the force T3. We have already talked about the Newton's third law. So this is the same string. In this string, if T3 is acting towards the rope, means towards M2, M2 will be giving an equal and opposite T3 in the same side because this T3 is acting in the same rope. If I have a rope here, different ropes are used. We can see because all the tensions are different. Different ropes are used to connect all the 3 bodies. Now, if I say here tension is acting, so will it not affect this part of the rope? Here we do not study or use any question like this, no, that this is the region of this block, this is the region of that block. This is not how we solve. For us, we have a block M2 here with this rope attached. Okay, we are not concerned with this block, but at least this rope is just in direct contact with it. So here we apply the Newton's action reaction. So T3 will be acting downwards. That is right. Okay. T3 will act downwards because T3 from the body M3 was going upwards. So for M2, it will be downwards because tension can never act towards the body. It is always away from the body. We have studied that. So one reason is that. Second is because of action reaction, it will act downwards. Simra, M2G, why the gravitational force is neglected? You told me the toughest part. This is just the toughest part. Students are not able to identify this. M2G, weight will always act, no matter what.
There as well.
Yeah?
Okay.
Okay, got it.
I did not consider that. That's why.
See, gravity will be all the time. Whether our system is zero is at acceleration 0 means the system is at rest or it's moving. One time you can forget another force, but gravitational force will always be existing. Okay, so whenever you have anything, just drop a gravitational force downwards. Your normal reaction can exist or it cannot exist. Tension can exist, it cannot exist, depends on the situation. If you have a contact with the surface, normal reaction exists. If a rope string is there, then tension exists. But gravity is every time, right? So you cannot neglect gravity. Gravity, mention gravity. Okay, now this whole system is going upwards. That's why I say draw the free body diagram. Now this is just the question that you need to solve. You don't have anything else to solve. Simra told the free body diagram. Neha, can you tell me the equation?
T2 minus bracket T3 plus M2G
Yes,
is equal to M2A.
correct. So you can just put the sign like -T3 minus M2G like this is equal to M into M2 into A. Then you can take the minus sign common and solve the way you have to solve the questions. Look, T2 minus T3 is 35.4. We've already calculated from here. Minus N2 is 2 into 9.8. So now your 56 something will work. Neha, 58.9. Right? Minus 35.4 minus this. So yeah, this is M2 is 2 into acceleration is 2. So T2 will be equal to 4 plus 35.4 plus 19.6. Now what is this equal to? 10. So here it goes 9, 1, 4, 5, 59. 59 Newton will be the answer. T2 will be 59. Now coming to T3. So now, sorry, T1, the first one. T1 is now easier to solve. Now you must have understood that this is T1. M1 body is there. Upwards, tension is acting. Downwards, M1G will act. This will be there. Apart from it, the action reaction will allow the T2 will act to act here, and acceleration like this will go up. Simra, you tell me the equation this time.
T minus T2 minus M1G is equal to M1A.
Yes, very good. Equal to M1A. So T1 minus T2. In this question, in some of the books, you will find that directly from T1. Okay, I'll explain that part, because if you're practicing from somewhere NCRT, you can get confused. I'll just tell you that. I will tell you, prefer this method. In this, everything will be clear, whatever values you have. This is minus 59 minus M1G. M1 is 5. So this is 5 into 9.8 is equal to M1 is 5 into 2. So this is 44 is there. So 45, 49. This will be 49. Will it be?
Yes. One second.
So 59 plus 49 plus 10. 118 Newton. Sorry, T1, not T2. This will be 118 Newton. T2 is 59 Newton. And T3 is 35.4 Newton. T1, T2, T3. Now see class, one thing I'll tell you here, pay attention. Then you can solve and write the things. See, in some solutions, you will find the questions have started from T1, and you'll find a very lengthy equation written, like T1 minus M1 plus M2 plus M3, then equal to M1 plus M2 plus 3 into A, something like this. So basically, it's the same thing. Like if I expand this equation, T2 was what? T2 was T3 minus M2G. T3 was what? M3G, right? This part, M3 into A plus G. If I keep on writing the variables in this rather than T2, which is just confined, I'll just get the same bigger equation. So that is what you will find. It will be very difficult for you to include everything. You have to keep in mind, okay, M3 also you have to include the force, M2 will also be included like this. Isn't it better you start from T3? You just answer it reverse. That's the only thing will happen. What will happen? Instead of answering T1 first, you will write T3 first. But at least you will have T3. Then that value can directly be put here. You don't have to write the variables multiple times. Otherwise, your T1 will be a very big equation, and most of the books have this solution. T1 minus M1 plus M2 plus M3, like this big equations are there. A into G and this into that. You'll be very confused. You will neglect one of the things. By mistake, you will forget one of the two things. Because these are just 3 blocks. You can get these 3 blocks attached to a pulley which is resting on a table. The friction is also acting. These kinds of questions come. So it can be confusing. So solve like this only. Start from the one where you are able to get the values easily. Now it says whole system is stationary. Whole system is stationary is the best part because your acceleration is zero, right? This was the answer to the first question. For the second question, look, for the second part, when I have block M3, tension is acting upward T3, downwards we have M3G acting. Now acceleration is zero. I'll straight away say T3 is equal to M3G. So T3 is equal to what was M3? Just check. T. So this will be nothing but 3 into 9 point. Got it? So like this even makes the calculation easier when you have the variables where the values are equal to 0. Okay. So yes, this will be 29.4 Newton. You have the value of T3. Now T2. Let me redraw it. In T2, you are going to consider for M2. Look, T2 will be acting upwards, T3 will be acting downwards, and M2G will be acting downwards, and acceleration is zero. So which we write minus and plus, you can simply write T2 is balancing T3 plus M2G. Did you get this?
Yes, ma'am.
Upward forces are balancing the downward forces. So T2 will be equal to T3 is 29.4 plus M2 is, what's M2 given?
2
Two.
kg.
2. So it will be 2 into 9.8, which is 29.4 plus 19.6, 49. 18, 19, yes. T2 will be 49 Newton. Coming to the first body, M1. M1 will be upwards, you will have T1, downwards, you will have T2, and here you will have M1. When acceleration is zero, here also the acceleration was zero. So when the acceleration is zero, we can say upward forces are balancing the downward forces, right? So when this is the case, T1 is equal to T2 plus M1G. So T1 is equal to T2 is 49 plus M1 is, what is M1?
5 kg.
5. 5 into 9.8. So 49, 5 into 9.8, this is 49. So you get 98. 49 plus 49, T1 is equal to 98. 10. Is this question clear?
Yes,
ma'am.
ma'am. Clear.
All right. So from that assignment only question you all have written, please start writing the solution. I'll give you some more questions and those we'll discuss tomorrow. The impulse and the first two assignments, impulse and that one.